Okay, this is 6.5b. We're going to look at two more examples of solving quadratic equations. And the first one is just a number question in terms of consecutive numbers. Consecutive just means back to back. And if it's consecutive even numbers, maybe I should even add further two consecutive positive even numbers. If we're looking for two consecutive positive even numbers, that could be like 4 and 6. They're next to each other on the number line if we ignore the odd numbers. So like 100 and 102, but the two we're looking for are going to multiply to 5,624. So let's give this one a shot. We're going to write a let statement here. We're going to let x be the first number. Which would mean the second number is going to be related to x. Well, how is it related to x? Well, if the first number is 4, the next number would have to be 6, which is 2 more than 4. So we would just add 2. So now we have x and x plus 2. And since it says product, product means multiply. So if we multiply these two, we should get this. And that's how we write our equation. So if we take x and multiply it by x plus 2, we should get 5,624. And now we have an equation, we just need to solve it. How do we solve? Well, expand and collect like terms. X times x is x squared, x times 2 is 2x. Move this to the other side. And now we have a quadratic that we can solve. So, if we want to solve this, we could try factoring. We're going to look for numbers that multiply to negative 5,624 and add to 2, which is pretty tricky. You kind of have to guess and check. So if you can guess those and check those numbers, that's a valid strategy. We'll come back to that option though. If you can't guess and check those numbers, you could use the quadratic formula. So you have two options. You could factor, or you could use the quadratic formula. So let's use the quadratic formula, and then we'll try factoring. So the quadratic formula is x equals negative b, so negative 2, plus or minus the square root of b squared, so 2 squared, minus 4 times a is 1 times c, negative 5,624. All divided by 2 times a, which is 1. So, we've got to figure out that discriminant first. 2 squared minus 4 times 1 times negative 5,624. We get a positive discriminant, which means we are going to have two answers. And now we just have to figure out what they are. No decimal, so we might get nice whole numbers. So let's give it a shot. We got negative 2, we'll do the plus first, plus the square root of 2250 over 2. And we get, which equals, I think I made a mistake. Let's try that discriminant again. 2 squared minus 4 times 1 times negative 5,624. Oh, we missed a 0. Wonder if you saw the mistake. Let's go back and fix this now. Put an extra 0 in there. Come on. There we go, 74. And if we use the negative, we get negative 76. Since the question wants only positive integers, we know that this is our answer, and we can reject our negative answer. So 74 is x. X is the first number. So our second number would be 74 plus 2, which is 76. And those are our two numbers. Consecutive, even, positive numbers. That's a number sign, not a hashtag. Are 74 and 76. Okay, back to the factoring. I said we could factor. Well, we can factor. We just have to figure out what numbers do this. And well, the numbers that do that are negative 74 and positive 76. So if you figured that out, you can get to the answer a little bit quicker, because 76 and negative 74 multiply to this and add to that. When you get a question like this, if you square root that number, the answer to the square root of that number is usually fairly close to one of the answers, which makes sense, because if you have two close numbers that are multiplying to get that, the square root would be the numbers that multiply by themselves. So it's pretty close. So you just kind of play around with the numbers around the square root and you figure it out. How does this help? Well, this one would give us our negative 76, which we would reject. This one would give us our 74, which is part of our answer. And the other answer just comes from adding 2 to get the 76. So you could solve it either way. You could factor it, or you could use the quadratic formula. Always try to factor first, but if you get stuck factoring and maybe it's not factorable, or you just can't factor it, quadratic formula is always there and it's got your back. All right, let's try the last example. Example 4, right triangle. One leg of a right triangle is 1 centimeter longer than the other leg, and the leg of the hypotenuse is 9 centimeters greater than the shorter leg. Find the lengths of the three sides. Ooh. All right, let's draw the right triangle. One leg is 1 centimeter longer than the other leg. Okay, so let's say let x be one leg. So x plus 1 would be the other leg. If one is 1 longer than the other, well, x would be 1 and the other would be x plus 1. Because if we had, say, like 5, one of them is 5, the other one's 6, it kind of holds true. So let's say this is x plus 1 and this one's x. The hypotenuse is 9 centimeters bigger than the shorter leg. So x plus 9 would be the hypotenuse. So how do we figure out three legs? Well, we need some sort of relationship between these three sides that we can make an equation. Well, there is a famous equation for right angle triangles, and that's the Pythagorean theorem. The Pythagorean theorem says that if we square one leg and add it to the square of the other leg, we get the square of the hypotenuse. We don't know the numbers for these sides, but we do know an expression that represents them. If we call this A, B, and C, x squared plus x plus 1 squared should equal x plus 9 squared. And now we have an equation we can solve. If we expand this all out, we should get a nice expression. So let's give it a shot. X squared plus, when you square a bracket, you write it twice. And now let's expand these brackets. FOIL, x times x is x squared, x times 1 is x, 1 times x is x, and 1 times 1 is 1. X times x is x squared, x times 9 is 9x, 9x again, 9 times 9 is 81. And now we're just collecting like terms. We got 2x squareds on the left side, so let's move everything to the left side. So we get x squared plus x plus x plus x plus 1 minus 9x minus 9x minus 81. Move those three. I missed this one. Minus x squared. And now let's collect our like terms. We got x squared plus x squared minus x squared. That's going to leave us with just x squared. We got x and x is 2 and negative 18. So we got negative 16. And 1 minus 81 is negative 80. So now we have a nice quadratic. Well, what can we do with that quadratic? We can solve it. Let's try to factor. Let's look for numbers that multiply to negative 80 and add to negative 16. 8 and 10, that doesn't work. Let's try, 20 and 4, might be onto something here. Negative 20 and 4. Those numbers multiply to negative 80 and add to 4. So we got x minus 20 and x plus 4. And now we just take each bracket, set it equal to 0 to solve it. X minus 20 equals 0. X plus 4 equals 0. So we get two answers, 20 and negative 4. And now we have to ask ourselves which of these answers are reasonable. Well, if we have negative 4 as a side length, negative 4 can't be a side. So this one is unreasonable, so we reject it. But we can accept 20 because if we use 20, our three sides would be 20, 21, and 29. So that's our answer. Therefore, the three sides are 20, 21, and 29. And of course you could show your math plugging 20 in for all those sides, but I think those ones are kind of implied. All right, that was example 4, and that's it for lesson 6.5, part 2. Actually, that's it for the whole unit. Thanks for watching, and I'll see you in unit 7/8.